Hello, everyone. My name is Wang, and I'm assistant professor at University of Illinois. Today, I'm going to talk about browser-level defense against IDN-based phishing attack. So imagine you were led to visiting this website, and everything looks like apple.com, even the domain names. However, it turns out this is a highly deceptive phishing website. If you take a closer look at the domain name and check its encoding, you can see that it is actually an Internationalized Domain Name, or IDN. So the character A in apple.com is actually a Cyrillic small letter A. The Unicode code is 0430. However, the real Apple's website has only Latin small letter A with a different encoding. Now, these two characters look like each other, but with different codes. So this allows the attacker to create a highly deceptive phishing domain name. So a little bit background. IDN was introduced around in 2013. It allows people around the world to use their own languages for creating domain names. So for example, Bücher is a German term, means books in English. So a bookstore website can use Bücher.de as its domain name, and it will show Bücher.de on the browser address bar. In the backend, there's corresponding puny code, which is the ASCII version of the domain name, starts with accent --, can use to work with legacy systems such as DNS. And the problem is that many different characters from different Unicode scripts, different languages, may look like each other, and this creates an opportunity for attackers to create highly similar looking domain names to do phishing attacks. So browser vendors have realized this problem and deployed defense. A common defense idea is to display a puny code when the browser detects an impersonation attempt. For example, this apple.com is IDN. It looks like the real apple.com, and the browser can just display its puny code version, and even through a warning message. However, we found that this defense policy is triggered inconsistently sometimes. So for example, sometimes when there's a website has a domain name that is clearly impersonating other popular domain names, and those policies will not be triggered. So this make us wonder, what kind of policies do major browser vendors adopt, and how effectively they are enforced? Also, we want to understand if there are ways to systematically bypass these existing defense policies to create a homograph IDNs. And finally, how well can end users recognize those IDN homograph domains? So we answer the first two questions using Blackbox testing framework to examine different browser vendors and different versions, all the way from 2015 to 2020. We answer the third question through a user study. So let's take a look at the Blackbox testing first. The first part of the test is try to understand the claimed policies of different browsers and how well they're enforced. So we take a bunch of browsers and find their public documentations. And we found that many browsers adopt very similar policies. So for example, many browsers will prevent the mixing of different Unicode scripts. So for example, this apple.com is a mixture of Latin characters and Cyrillic characters, and this is no longer allowed in many browsers. Other browsers might only allow certain Unicode blocks or scripts to be mixed. For example, typically Chinese, Japanese, and Korean characters can be mixed together. There's a rule called a skeleton rule, which is to match a given IDN with the skeleton of a short list of top domain names. So for example, this google.com match the skeleton of google.com, the real google.com, and therefore this domain will be flagged. Another rule is called host script confusable, meaning that sometimes the attacker can craft a domain name with only characters from a single Unicode block. For example, this apple.com is every single letter is Cyrillic letters. So therefore, there's no mixing. So the browser has to look for additional evidence of impersonation by checking the TLDs. Other policies and rules are quite self-explanatory. So through this kind of policy mining, we crafted 5,000 testing cases, testing IDNs, to test if these policies are well enforced. The second part of the testing focuses on evasion. We construct potentially evasive testing IDNs to see how browsers react to them. So for example, we observed that the browsers are using a list of confusable characters from the Unicode standard to support their policies. However, this list is largely incomplete. So we basically craft evasive IDNs through a more extensive list of confusable characters. Another idea is that the browser are maintaining a small list of 5,000 domains as the popular domains. However, there are many important target domains that are not on the list. For example, regional hospitals may be a good phishing target, but there's not on the popular list. Host script confusable has also weaknesses because we can find the right TLDs to craft an evasive IDN. And finally, within the prohibited script, we found certain Unicode blocks can still be mixed. Through these ideas, we crafted 3,000 testing IDNs to test evasion feasibility, and together we got 9,000 testing cases. So in order to automatically run those tests across different browsers, different versions, and different operating systems, we built a testing framework to do this automatically. So the idea is that we instrument the browsers to load the testing IDNs and at the same time perform screen recording to record how the browsers react to those domains. So as you can see, our testing covers a large set of browsers and different versions, including both their desktop versions and mobile versions as well. So after capture the video recording, we developed a image analysis framework to classify if the browser has displayed the Punycode or the Unicode. So here is the quick look at some of the results. So we look at the latest versions of the browsers and show that out of the 9,000 testing cases, how many cases are showing or displaying the Unicode. Showing the Unicode means that the defense policy was not successfully triggered, therefore the defense failed. We found that all the browsers have failed on certain testing cases, and in comparison, Chrome is the relatively stricter one that has the lower failure rate. So we then plot their policy changes over time by checking the different browsers and their versions along the time axis. So here in this plot, the x-axis is the time and the y-axis is the failure rate. So I wanted to point out, this is only for the evasion test, and I wanted to point out a few interesting points. So the flat curve at a 0 failure rate means that the browser has not yet supported IDN. So Chrome, as you can see, is the first browser that supported IDN, and they become immediately vulnerable after supporting IDN. Over time, browser like Chrome has major updates on their IDN policies to reduce the attack surface. Very interestingly, in early 2019, we found that Chrome have revoked some of their IDN policies to re-allow certain Unicode blocks, such as Latin extended A. So the reason we suspect is that those rules are too aggressive and might have hurt legitimate domains. Also, we observed that Firefox and a Safari policy have not had major updates for more than 2 years. So overall, we showed that browser policies are improving, but there's still a large room to do further improvements. So the question is, are there real-world IDNs that impersonate real-world websites? So the short answer is yes, right? So we did a quick analysis over the .com zoom file and analyzed 400 million domain names. We found 900,000 IDNs, and about 1,800 of them are impersonating the top 10K websites. So here are some examples. So we threw those domains into the latest version of different browsers and found that they were very successful bypassing their existing defense policies. So the results confirms our concerns. So we also had a user study to study whether users can effectively recognize homograph IDNs. So we found that homograph IDNs that already bypass the Chrome defense are still deceptive to users. So further details can be found in the paper. So in terms of countermeasures, we have a few ideas. So for example, you can specifically fail adding new policies to fix or to patch the failed cases. However, it is difficult to guarantee completeness using this ad hoc approach. Another idea is to use visual similarity metrics like perceptual hashing to systematically detect impersonation against a wider range of domain name. The problem is scalability, and it's hard to do this in real time if you wanted to cover a large range of legitimate domain names. So there might be a trade-off we can make. So for example, we can disable IDNs by default and only show the Unicode of the IDN when the languages matches user-specified language in the browsers. So for example, I speak English and Chinese, and I can be more permissive on IDNs with those languages and more aggressively detect homograph IDNs from other languages. So in conclusion, we did an empirical test on major browser vendors and their IDN homograph policies, and we found there are various weaknesses. We have reported the results to the corresponding browser vendors. So thank you for your time, and I'm glad to take questions from the audience.